Okay, number 10 in your classwork for congruent triangles tells you that the information in the figure, we want to find if the information in the figure can be used to prove that triangles ACB and triangle CAD can be congruent, and explain. So we have, if this is to be true, then angle A of the first triangle, so we have the first triangle given here, ACB, and the second triangle is CAD. So if this is to be true, then angle A of the first triangle, so this angle, must be congruent to angle C here, and by the marks that they gave before, this is true. So we have angle A is congruent to angle C. Then it would have to follow that angle C of the first one, so we have two dashes here, is congruent to angle A of the second, so we also have two dashes there. So this is true. So angle C is congruent to angle A. And lastly, angle B would have to be congruent to angle D. And we can prove that this is also true because if we have these two triangles which have two congruent angles, then it would follow that the measure of angle A of the first one would equal the measure of angle C of the second, and measure of angle C of the first would have to equal the measure of angle A of the second. So we know that the sum of all the angles in the triangle must equal 180 degrees, and if we have two of the same angles, then what's remaining, that one angle, B and D, must also be of the same measure. So we have that the measure of angle B is equal to measure of angle D, and so then that follows that angle B is congruent to angle D. Okay, so we have the angles all done. Now we just need to check on the sides. So we know that side A of the first, so this one, given by two dashes, corresponds to side A must be congruent to side C, which is this one. So that's true, because we also have the marks of two dashes there. Then side C, so this one, would have to be congruent to side A, which is this one. So that's also true. And lastly, side B would have to be congruent to side D. And actually, that's easy to prove because that's the shared line in the middle. So it has to be true that if segment AC is congruent to, or first of all, it has to be equal in measure to side CA, then it would follow that side AC is congruent to side CA, and if we use just a different notation, then that would be side B is congruent to side D. And so we can say that using the information in the figure, we have proved that triangles ACB and triangles CAD are